everyone and welcome to my YouTube channel uraveragecoder. This is your host Pratik Nandani and today in this video we will learn about stacks and queues. So first let us take a look on what is stack. Stack is an ordered list in which insertion and deletion can be performed only at one end, that is called top. Stack is a recursive data structure having pointer to its top element. Stacks are sometimes called as last in first out, pronounced as LIFO lists. That is, the element which is inserted first in the stack will be deleted last from the stack. Now let us take a look at operations on a stack. First one is push, which means adding an element onto the stack. Second one is pop, which means removing an element from the stack. The last one is peek, which means looking all the elements of the stack without removing them. So here is a table showing status of stack at different top positions. At position -1, the status of stack is empty. At position 0, only one element is there in the stack. At position n-1, the stack is full, and at position n, the stack is overflowed. Now, how the stack grows? Let us take it into different scenarios. Scenario 1 is if the stack is empty. The stack is called empty if it doesn't contain any element inside it. At this stage, the value of variable top is -1. Scenario 2 is if the stack is not empty. Value of top will get increased by 1 every time when we add any element to the stack. Scenario 3 is deletion of an element in the stack. Value of top will get decreased by 1 whenever an element is deleted from the stack. So now let us take a look on some different algorithms for operations on stack. First one being algorithm for push operation. Step 1 is checking if the stack is full or not. Step 2 is if the stack is full, produce an error and exit. Step 3 is if the stack is not full, incrementing top to point next empty space. Step 4 is adding data element to the stack location where top is pointing. Step 5 is returning success and exiting. The second one is algorithm for pop operation. Step 1 is checking if the stack is empty or not. Step 2 is if the stack is empty, produce an error and exit. Step 3 is if the stack is not empty, access the data element at which top is pointing. Step 4 is decrease the value of top by 1. Step 5 is returning success and exiting. So now let us take a look at what are queues. A queue can be defined as an ordered list which enables insert operations to be performed at one end called rear and delete operations to be performed at another end called front. Queue is referred to be as first in first out. For example, people waiting in line for a rail ticket form a queue. The below picture depicts how a queue works. Now let us look at applications of queue. Queues are widely used in waiting lists for a single shared resource like printer, disk, and CPUs. Queues are used in asynchronous transfer of data, for example, pipes, file input outputs, and sockets. Queues are used to maintain the playlist in media players in order to add and remove the song from the playlist. Queues are used in operating system for handling interrupts. Now let us take a look at what circular queue is. Deletion and insertion can only be performed at front end and rear end respectively as far as linear queue is concerned. Consider the queue shown in the following figure. The queue shown in above figure is completely filled and there can't be any inserted any more elements due to the condition rear double equals to max minus 1 becomes true. However, if we delete two elements at the front end of the queue, we still cannot insert any elements since the condition rear equals to max minus 1 still holds. This is the main problem with the linear queue. Although we have space available in the queue, but we cannot insert any more elements in the queue. This is simply the memory wastage and we need to overcome this problem. One of the solution of this problem is circular queue. In the circular queue, the first index comes right after the last index. You can think of a circular queue as shown in the following figure. Circular queue will be full when front equals to -1 and rear equals to max -1. Implementation of circular queue is similar to that of a linear queue. Only the logic part is implemented in the case of insertion and deletion is different from that in a linear queue. So now let us take a look at insertion in circular queue. There are three scenarios of inserting an element in a queue. First one is if rear plus 1 whole mode max size equals to front, the queue is full. In that case, overflow occurs and therefore insertion cannot be performed in the queue. Second one is if rear not equals to max -1, then rear will be incremented to the mod of max size and the new value will be inserted to the rear end of the queue. Third is if front not equals to 0 and rear equals to max -1, then it means that queue is not full. Therefore set the value of rear to 0 and insert the new element there. Now let us take a look at deletion in circular queue. To delete an element from the circular queue, we must check for the following conditions. First one is if front equals to -1, then there are no elements in the queue and therefore this will be the case of an underflow condition. Second is if there is only one element in the queue, in this case the condition rear equals to front holds and therefore both are set to -1 and the queue is deleted completely. Third is if front equals to max -1, then the value is deleted from the front end. The value of front is set to 0. Otherwise, the value of front is incremented by 1 and then delete the element at the front end. Thank you for your attention.